Okay, what did you guys get for your numbers? So read them off.
4.
4.
2.
4. 2.
0. -2. -4.
5.
3.
1.
1.
-1. -3.
3.
1.
1. -1. Right? Yep.
That's your values?
Yep.
You sound so enthusiastic. All right, so you just got that from this formula. So did everybody get those values?
Yeah.
So you're just plugging in the y value, so 0, and then subtract out 2 of the x values. So minus 2 times -2. Okay, so let's go ahead and sketch in our points. So at -2, 0, I have a slope of 4, so that's very steep. Okay, at -1, 0, I have a slope of 2, so about a half as steep. 0, 0, I have 0. That one doesn't always happen. All right, 1, 0, I have -2. It's kind of symmetric. 2, 0, I have -4. Okay, -2, 1, I have 5, so even steeper. -1, -1, or -1, +1, I have 3, so a little bit steeper than the one below it. 0, 1, I have 1. 1, 1, I have -1. 2, 1, I have -3. -2, -1, I have 3. -1, -1, I have 1. I can't really tell on this one. It's looking weird. 0, -1, I have -1.
Ew.
1, -1, I have -3. Were these always -3? So all the things, no, they weren't. And then 2, -1, I get -5. So really steep.
Wasn't that negative? Oh, yeah. Yeah.
Okay, we're going through the point 1, 0. So go over 1, 0. So it's some kind of, it looks kind of like a parabola. I think it's a little, not quite a parabola. Because it's not perfectly symmetric, right? Okay, so it says you can check solutions with Grapher. So let's actually look this one up on Grapher.
Error.
Okay. There's some way to put the, stop this really too. So click on equation, new equation from template. We want a first order. So first order means just y prime, not y double prime. Second order would be y double prime. Okay, so what was the equation that we had? So y prime equals x plus y. So where it says dot, 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 delete that and write x plus y. And then we had y of 0 is equal to -1. Is that right? -1? Or 1? 1. Thank you. So hit enter. Did we get a curve like that?
No.
Oh, ours went down.
Oh, no, that's the first one.
You gotta go up.
The first one was the
We
one
did
that
it,
you're
right?
talking about.
Oh, that's the first one. Okay, that's the first one we did. Okay, now what's the next one we did? Y minus 2x and y0 equals?
1 equals 1.
No, it's y1 equals 0, right? It was the point 1 comma 0.
Yeah, that is right.
Is that what we had?
Yeah, that's what we got.
Yep, that's it. So you can check your solutions with Grapher. So it's kind of nice to check.
So did we do it right?
Yeah, we did. All right. Okay, so it says there are many differential equations that can actually be solved. So in fact, there's a whole branch of mathematics that's devoted just to this topic. So there's all kinds of differential equations you guys can take. It's especially good if you take this if you're going to be an engineer. Like you'll definitely need differential equations for anything like physics, engineering. You need differential equations. All right, it says the ones you need to know how to solve for the AP Calc exam are called separable differential equations. All right, so separable means that you can separate your two variables, your x and your y. Okay, and then you just integrate on both sides. So y prime is equal to dy over dx, so derivative of y in terms of x. So we always write it in that form. Okay, we're going to try to separate so that I have all my x's on one side. So it's going to look like something with dx and something with dy. So all my y's on one side, all my x's on one side. So see how you can multiply the dx over, so I get sine of x dx. You're allowed to do that if you think of units. Remember when we talked about related rates, think of units. So these units go over here with these. All right, now I'm going to divide by y squared. So I get y to the negative 2 dy. So I divided my y squared over. So you could write 1 over y squared as well. Because I divided it over. Let me write the step in between. So this is 1 over y squared. So it's y to the negative 2 dy sine x dx. Okay, and we integrate both sides. Okay, so I get y to the negative 1 with a negative 1 out front. I'd usually write plus c, but I'm just going to write the plus c's with the x's. Because if I had a plus a constant on the left side and plus a constant on the right side, you could just subtract the constants and get them on one side. Like if I had plus 5 and plus 2, I could subtract the 5 over. All right, so when I integrate sine, so negative cosine x plus c. All right, sometimes they'll let you leave your answer like this. Usually they don't. So this is negative 1 over y. If it's a multiple choice question, you'll see the different setups. Okay, so I need to take the reciprocal of both sides. Or you can think of cross multiplying. I'd have negative 1 equals y times all of that. I just think of if I'm trying to get the reciprocal of this side, I'm just going to flip it. So I get negative y equals 1 over negative cosine of x plus c. So it's y equals, divide by negative 1, so 1 over cosine of x minus c. You could write minus c if you want, or just plus c. I'll go ahead and write minus c. Okay, so that would be a form of your differential equation. Now usually with the c, the constant, that comes from your initial thing. So like before, remember how we had like y of 0 equals 1 or y of 1 equals 0. So usually we're going to have to find c, but on these first ones I didn't have you guys do that. Yeah, Ayush, do you have a question?
When you go from y to the negative 2 dy, you get plus c here.
Here? Oh, that's what I was saying, yeah. You can write a plus c on this side or plus d because you don't want them to be the same. But when you subtract your d over, it's still just a constant here. So usually what we do is we just write plus c on the x side.
Do they care if you write for the final answer, if you write minus c or plus c, because it doesn't really matter.
It doesn't matter. On these ones you could have plus c there. That's fine. I just kind of wanted to get in the habit of distributing my negative because when this is a number, you're going to have to do that. You know, like when you actually find what that number is. All right, so let's try the next one. So try to separate it.
That's an acronym, George. It's an anagram.
So I need to multiply this whole denominator over to be with the dy. You're never going to have dy on the bottom, too. I mean, you don't integrate with it on the bottom, right? So I'm going to have y square root of 1 plus y squared equals, the dt is going to go over here, so I'm going to have t e to the t dt. And then I'm ready to integrate. Okay, this one's a u substitution. Did you guys see it? So you're going to let u equal 1 plus y squared. So du is 2y dy. So 1/2 du equals y dy. So you're going to have 1/2 out front, the integral of square root of u, and y dy is replaced by the 1/2 du. So the 1/2 is out front, du. Equals, this could be an integration by parts. Did you guys see?
No,
I did not see that.
So really you shouldn't let them be u as well, but we'll call it w. W and dv.
Oh.
So w is t, dw is dt, dv is et, so v is also et. So I have w times v, so t e to the t minus the bottom row, so e to the t dt. Okay, so keep going. So I get 1/2. Erase this so I have more room. 1/2. This would be u to the 3/2 with the 2/3 out front. So 2/3 u to the 3/2. So u was 1 plus y squared to the 3/2 equals t e to the t minus e to the t plus a constant. All right, let's just tidy this up a little bit. Let's write it as 1/3 1 plus y squared to the 3/2 equals t e to the t minus e to the t plus c. Now, if I wanted you to solve for y, what would you need to do?
3 times.
You'd multiply by 3 on the first. You do that first. Then you'd raise it to the 2/3 to get rid of the 3/2. Subtract 1 and take the square root. I'm not going to make you guys do that. So that one, you can leave like that. All right, so you guys can start on your homework.